You want to do what? You want to build a solar powered cargo trailer? Have you lost your mind? You can't do that. Well, you can. I did it. So, if you want to see how I did it and learn how to do it safely to where you don't get anybody hurt, hopefully you don't get yourself hurt doing it. I almost fell off of mine doing it. But anyway, this is how I did it. I'm going to show you pretty much detailed steps about how I went about doing it, what I bought, what I used, how I put it all together, even how I figured out what I needed. So come along in this video and you can go tell your buddies you got a solar powered cargo trailer. Yeah, they're going to tell you you're nuts too. All right, anyway, let's go do it. All right, I got my solar panels from Santan Solar. At the time, they were in Savannah, Georgia. Now I think they've closed that shop there, and you have to get them from, it's Arizona. What's that, Scottsdale or somewhere out in Arizona. Anyway, just look up Santan Solar, and you can buy them by the pallet is the cheapest way. I bought 8. I put 6 on top of the trailer, and I still have 2 left for a project that I'll be working on again. Said I'd have it done by now, but I haven't. Gonna put them on my garage to run the refrigerator that's there. Anyway, get them from Santan Solar. Look them up there on the web. All right, next we need to look at how we're gonna mount them. So this is the top of my cargo trailer. Now mine is 24 feet long. That does not count the V nose, and I didn't count the V because the top of the trailer, I was figuring it to be square just like the panels. I didn't want to have anything up in the extra 1.5 2 foot, whatever it works out to be. It goes from 0 to like almost 2 feet by the time you get to the V. But when you get on the top, just make sure that you have it really clean, because that's probably the last time you're going to get to clean it like it looks right there. And you can see about halfway up further, you'll see the brackets I had made that mount to the side of the trailer. And they're made out of metal and they've been powder coated. Now, this is on the inside. That's the fender well. So the fender well seemed like the place to me that would be the best to haul the extra added weight without having extra tongue weight, since I went through so much trouble making sure that I had my weight distribution right to begin with. So went in there and framed up. I already had my battery, so I knew the width and the height and stuff. So I went in there and framed up from the fit here. There would eventually be 4 batteries stacked, and it's full. All right, what I used is it's readily available anywhere. It's called Unistrut. Unistrut. That's why they call it Unistrut. It is universal. It's good for a lot of things. But you can go to any of the big box stores. Even mechanical warehouses and stuff will have it. And you can get all these fittings that go in there. And you can see the screw and the spring nut. You just want to get the right size. I opted for 3/8. So everything that you see me mounting with is a 3/8 bolt. And I believe these were standard SAE type threaded bolts. I don't remember these being metric now. I'm going back on memory, and sometimes memory doesn't serve me as well as it did 40 years ago. But anyway, all this is 3/8. Okay, I opted to spray paint my Unistrut before I mounted it. I know it's not supposed to rust. It has a coating on it, but it will eventually, and even with the paint, one day, as it gets nicks and stuff on it, it will probably start getting some rust. But for now, it looks really nice. Matches all the black on the trailer. All I did was wiped it down with some stuff that's called Prep-Sol, and it cleaned it up really good. And then I painted it. So this is a look at the outside of the trailer. This is where I mounted my side mounts. I had these made at a local shop. They do welding and build trailers and that type of stuff. And they're made out of a piece of plate metal, and then they heated them, bent them to a 90 degree, and then they put a small gusset on the inside of them to keep them from flexing. And then I went on the inside of the trailer And on my trailer, the top rails that makes the frame at the top, its bars goes all the way around. Most of them are 1.5 by 1, or they're just 1 by 1 square tubing. You can go back. There's a video where I special ordered my trailer, and I had mine double stacked. So mine has two 1.5 inch by 1 tubing rails all the way around the top of the trailer. And I did this because I knew eventually I was going to add all this weight to the top, and I didn't want any flex. So keep that in mind if you're in the stages of going to build a cargo conversion, that you might want to do that when you order it. It was not that much more to have that done. But anyway, I went on the inside and identified there was there's 3 inches there. I wanted it in the bottom rail, not the top one. The top one is, you can see the aluminum goes around it. Anyway, I figured out where the 2 holes needed to be, and went ahead and placed my brackets there, drilled the holes, and mine have nuts and bolts all the way through the rail. So there's no way that's ever coming off short of a major catastrophe, and at that point I don't think it's going to be worth salvaging the trailer. So I probably overbuilt this and overkilled it, but safety was my first priority. So that's how I arrived at where I'm at, and that's how I've got them mounted. So take that, and we'll move on to the next slide here. All right, again, you're looking at the top, and I think I'm at the front looking to the back now. Yes, I am. I'm at the front looking to the back, and you can see I've mounted 4 of the bars across. So I did this with again with 3/8 bolts on the outside, and I believe these are 1/2 inch bolts that I actually put the unistrut and the 2 brackets together. Pretty sure that's right. I think that's the only 1/2 inch I used in the whole thing, but it just seemed to fit the unistrut better, and I did. I used half because I drilled out the brackets to fit it. So anyway, that's how I mounted those, and then it continues on toward the front. Well, this is my buddy Bob. Everybody needs a good helper, so I got Bob the builder to help me. So what he's doing is now you notice the 2x4s I've got up there. That's to keep from putting any undue stress on my roof. But what he's doing is he is taking the 3/8 bolts and putting them into the unistrut where I showed you the spring nuts. So he's mounting the bracket to the spring nut. Now when you do this, you guys want to make sure that you get all your panels squared up and looking identical, and get the symmetry looking right on them. Then you want to take that bolt back out once you've got them all in place, and very carefully put you a little bit of Loctite. That's what it's called, Loctite on there. And I'll tell you in the next slide how to use that stuff. But put it back in, and then tighten it back down. They'll never loosen back up unless you want them to. So that's what he's doing here. He's getting everything squared up, and then actually putting the Loctite on it. So once you've got that done, you can see here it all looks nice and even, and the symmetry of it looks really nice. So you can see the Loctite there on the right hand side, and we probably used a little more of that than we should have, but I'll guarantee you it ain't coming off of there. They've been on there now almost 2 years, and I've never had any kind of movement out of them. So that's what it should look like once you get everything mounted to your unistrut, got it the way you want it. And then we ran the wires and cleaned them all up, and got them hid away where you can't see them. So I'll show you that a little more here in a few minutes. Okay, so I decided to take the drone and go outside and show you what they look like now. This is over 2 years later. I don't remember exactly how long it is, but it's at least 2 years. You can see they're dirty. It's about time to clean them. I usually clean them up in the springtime. I did not do it this year. I did it last fall, I think it was. But even with the dirt that's on them now, it's not a problem pulling the power out of them. It just sits out there and does its thing. These little black pads you see on the back, it's because I got security cameras. You can see 3, got one on each side and one on the back. They're solar powered, so those little panels keep the batteries charged up. That's all it is. It has nothing to do with actual solar install. I just put them there, and yes, I know I blocked a few of the panels, but It doesn't affect those panels at all. I guess because I got them on the outside edges, I don't know, but it does not affect the panel at all. And a lot of people will argue that if you shadow part of a panel that it kills that panel, but in this case it does not. So however that works. Now you can see I brought all the M4 cables that connect all these together, and I put them end to end where the cable connections were, right here where I'm showing you at the cross. And you can see I have some loom that I've put all these wires in and ran it up where you can't really see the wires, and it also gives it some UV protection. Even though the wires are UV protected, I just chose to do it this way because, well, I just like to overkill everything, I guess. But everything's pulled up with zip ties. All of my wires are ran inside the unistruts out to this part here. Then it runs down. I even built a unistrut frame that goes between these panels around the vent there. So we'll go out here and turn around and come back and let you look at it from the front side. And you can see right here where I came off the front, and I got a piece of anodized aluminum off of Amazon, and I ran it down the front. You can see it coming off the front right down behind the mini split. Goes all the way down the front, and then I brought mine in through the floor and came back up. I just don't like putting holes in a roof you don't have to. I also don't like putting holes in the front of a trailer if you don't have to, because of the rain. If you're driving rain, especially if you are driving in the rain, you're just looking for a leak. But you can see how I come up on top and then turned it. I mean, really, this is all you see. Just goes down between the panels. Looks really nice and clean. Like I said, I got the unistrut even around the power vent there, just so I'd have some place to lay the wires and strap it down and keep it really nice and clean looking. So hope you guys like the way that looks. I was thrilled with it when it was done. Again, you're just kind of getting an overall view of how I mounted all this stuff. So you can see where the unistrut and the brackets I had made come together. They they're double bolted, and then you can see there where it goes into the spring nut with the 3/8 bolt. Again, all this stuff was Loctited, and not only is it Loctited, some of this stuff I put a nylon nut behind them. Not the ones for the panels, but the ones on the bottom. There's a regular nut that's Loctited, and then there's a nylon nut under what they call a nylock. So again, I don't know, just safety conscious, I guess. And then you got the two bolts that go in right there that go all the way through the side. And they bolt to the inside. Now, again, I told you I had the top of mine double banded, an 1.5 inches. So there's 3 inches right there, and you got a bolt goes through both of them. I originally was not going to do one through the aluminum at the top, but I did. And again, it's got they call it 3M tape. I've got them 3M taped to the side, and I did it for 2 reasons. One was just to stick it up there where I could put it in place to do all my measuring. And then the other one was it actually makes a pretty good seal, water seal. So I did that, and then when I got finished, you can see I removed the cap off this one right here. You can see I actually siliconed the around the head of the bolt, and then squeezed the cap back on top of it just to make sure there was no way for water to get in from around the outside edge. Then I put these nice little plastic caps on them just to make them pretty. But anyway, just trying to show you a really good detail about how I did this in case you guys are trying to figure it out. Well, I thought I'd shown you enough here, but actually I looked at a little bit more of the footage and wanted you to see a couple more things. One is this is a lot better close-up of the brackets and how they're made. I have 2 of the Victron MPPT 150 charge controllers, and mounted them. There's 3 home runs from each solar array, so I have a total of 6 panels. So it goes from the charge controller down to these blocks, just so I can add a 50 amp fuse. These are just pass-through blocks. These are not breakers. The other breakers are DC breakers. Do not use an AC breaker. DC's for direct current, AC's for alternating current. Alternating current is found in your homes. It is not supposed to be used for DC. Also, although you do have AC in these trailers, that's not what you're working with when you have solar. You're working on DC at this point. So make sure you use DC. All right, moving on. These are what they call maxi fuse holders. And they hold a 50 amp max fuse. Now, a max fuse, if you lay it out beside a regular car type blade fuse, it's about 5 times the size of that fuse. So these are 8 gauge wire fuses, so they will more than carry the amps that I need them to carry. But that's what I used. It's called a max fuse and a max fuse holder. You can decide if you've got a bigger solar array than mine, you may need a bigger one. If it's smaller, you could get away with a 30. They do make a 30 max, and I just like the max because the older I get, the easier the fuses are to grab if they're bigger. So that's what I used on here. Okay, we opted to use 4 of the Chen's 300 amp hour batteries, and I ran them. You can look here. I don't really know if you can tell, but I ran them. There's 2 sets of 12 volt batteries. That makes 24 volts. So I have 2 sets of 24s because I ran 2 sets in series, not parallel. So I paralleled the 2 series. And for some of you that may not make a whole lot of sense, but if you look up how to run series, it goes from positive to negative, and then the negative to the next positive, and then the negative, and you pull from opposite ends, from the positive to the negative. And I'm probably butchering that up real good, but there's some really good videos out there about how to do it. Will Prowse, yeah, Will Prowse. Go look him up. He explains it for idiots because I figured it out from watching his stuff. But as you can look on there, you can see that's the way mine are wired. They just jumped red to black, black to red, and so on. So anyway, I did that, and then I ran them out to bus bars, and you can see the bus bars on the front. That's the easiest way to make a clean connect, and then move it to the next source. Now at the front of the box, closest to the bottom of your screen there, you can see there's a Victron shunt, and that's run off the negative side. So it comes off the negative side of the bus bar because the bus bar's got both sets of batteries hooked to it. So that's where you'd want to get your true reading for your 24 volts for the whole bank. So you'd come off there with your negative to the negative side, and it'll tell you battery side and stuff on the shunt. Just make sure you put it on the right side, but put it to the battery negative side, and then the other side will go to your source. Now that's going to tell you with the Victron app how many amps you're pulling. So it's really important to have one of those so you can see the health of your batteries and how your system's working. There's a lot of other things you can do, like getting a servo. I do not have that. That was extra $500, and you'll see here in a minute I use an iPhone for it. So it's not quite as nice, but it tells me what I need to know. On the inside, we use a pure sine wave inverter. It's the 3000 watt, and it's 24 volts. We're running a 300 amp fuse and a disconnect. We're pulling power, building a little heat. Now the fans have come on. It doesn't really affect the operation of it. It's minimal as how much it's pulling on it. So overall, we're really happy with the Victron and the pure sine wave inverter. Okay, I came from the inverter back up to the front of the trailer. All my electronics are up in the very front, right behind the wall of the in the kitchen of the sink area. You can see the sink there in the picture, way over in the back of it. But I have a door on the outside that I actually put in myself, and it opens up, and you can look right at the back of that wall right there. And that's where I decided to mount everything, to make it easy to access and service. But you can see the big black wire that's got the red wire tied to it there on the left of your screen. It kind of goes up to the silver box at the top. Well, that silver box at the top is a transfer switch, and that black wire is my shore power. It goes over to the other side of the trailer. You can see at the bottom going along the wall there. That's my 30 amp service. So it comes in and goes to the top, and then it goes into the transfer switch, and then it goes to the power panel right below it there. And that is a regular RV panel that you'd get in any RV. Bought it off Amazon, or you can go to an RV center and purchase one of them. But that has your one side of it is your AC 120 side with breakers, and then the other side of it has a 12 volt inverter in it, and it brings it down for all your 12 volt appliances and lights and stuff, and it has the regular 12 volt fuses in it. So I opted to go this way, just made it really easy to add things to it later. That little box on the left, that black one, in case anybody wants to know, that's my touch control panel on the inside. I have touch control for all my lights, outside, inside lights, anything that's switchable inside is on that touch pad. Also got it off of Amazon. If I remember, I'll put it in the link in the description. But anyway, that's just trying to tell you what all this stuff is, and then it's a big breaker with a clear panel on top of it up there for the 12 volt side for everything that's going to that touch panel. It's just a fail safe. It actually has blade fuses in the black box there, but I just like a fail safe in case anything gets shorted out between there and the main power source. Again, I'm probably overkilling things, but safety first. I got 3 fire extinguishers, one in the front, one at the door, one at the back. Same deal with the what they call them, O2 sensors and smoke detectors. I got 3 of those. So I'm getting off line here, but anyway, go back to the transfer switch. You go up to the transfer switch. Well, on the opposite side of that, there is another side, and it's for the generator side. Now, if you're going to use a generator and you plug your generator in and turned it on, actually, I'm telling you wrong. On this one, it would be an onboard generator. It would be wired in. So when you turned your generator on, it would automatically switch the power. And then when you turn the generator back off, it would automatically switch back to shore power. In my case, I'm using the generator side for the solar side. So my inverter actually feeds the other side of this. As you can see in this picture, I have brought the wire from the inverter that you saw a few minutes ago that had the, I think that's a green, a white, and a red wire. That's what's in this big cable here. So I brought it from the inverter through a 1.5 inch plastic tube under the trailer and bring it back up through the floor right here. Again, I don't like making holes in the walls and stuff, so I try to bring stuff through the floor and then protect it from the bottom. My trailer has 4 inches of spray foam under it after I got all this finished, so it's well protected. Anyway, you come up and it goes into the other side. So the transfer switch is a dumb switch. I know you've heard of smart switches and dumb switches. It's just a dumb switch. It has no technology to it at all, except that it senses power. It knows if there's power on one side or the other. So if I'm plugged into shore power and the shore power goes out in the campground, and I know it's never happened to none of you, but when it does, it doesn't know the difference. It just switches over to the solar side, and I'll start hearing the inverter running and stuff. But when the power comes back on, it will actually flip itself back over to the shore power. Now you'll hear it clicking, and sometimes you see the lights flicker. And when it does go from inverter power back to shore power, my lights do go off for 30 seconds, and that's how I know it's going back. And it's just a fail-safe. It's just making sure there's a clean cut between power, in case the power is bumping on and off when they're trying to get power restored. It's just a fail-safe. Anyway, that's all that is. That's how I did mine. That's why mine sits out back here when I'm not using it for a month or 2 at a time. Right now we're at 3 months, but we've had some issues with family, and you guys know that if you watch our videos regularly. But walked back there yesterday. Fridge is still cold. Air conditioner was at 75. Still felt good in there. It just runs. It just works. I don't have to worry about plugging it up. It just does its thing. Now, when we get to a campground, I will plug up, just so I don't have to worry about power consumption at night, or if you got a couple of bad days of sun where you got rain or something, we'll go ahead and plug up, but otherwise not. Also, with this setup the way it is, I was talking about generators. Even though I've got my solar on the generator side of the switch, you can still hook a generator to the 30 amp service. If you're not hooked into a pedestal, hook it into the generator in the back of the truck, turn it on. It doesn't know that it's not the pedestal that it's getting its shore power from, so it will run off the generator. If the generator runs out of gas 2 in the morning, guess what happens? It switches back over to solar. So it doesn't matter. It just works really good this way. I liked it as a setup. I researched a lot before I started trying to build this because I wanted it to be a really simple setup that was so easy to use that even somebody that doesn't know how my trailer works, they just know when they plug it in that it works. And if they unplug it and get ready to travel, then they ain't got to worry about the refrigerator and stuff staying on. It just works. So that's the reason I went with the setup I got. Hope this helped you guys out a little bit more, and I hope I haven't rambled on too long with how I did all this, but I thought it was important to take a little bit of time and just discuss the things as they come along. There's a lot more to discuss here. I mean, I'm just really scratching the surface. If you guys have any specific questions, you can put it in the comments below, and I will try my best to answer every one of them and explain to you in detail if there's a question that you have about how I did something or where I sourced it from or why I did it that way. And if you guys have a better way, and in 2 years, man, technology changes, and I'm sure there's some better things out there, let me know, because if you've been following us, you know we just bought a Class A diesel pusher, and you know I'm going to put solar on it. So I'm doing all my research and studying on it, and I'll probably start on that next year. Well, I said I'd talk about what I use to monitor my system, and I use an iPhone. It's an old iPhone. In fact, it was my wife's. She got hers upgraded a couple of years ago, and I decided we just keep this instead of trading it in, and I'd use it for this. But you can see with the Victron, you can see the Smart Shunt at the top, and then the second item down is the Solar Array 1, which is all the solar on the left side, the driver's side of the trailer from front to back. Solar Array 2 is passenger side front to back. It's 3 panels each. You can see at the top the shunt is showing that I have 26.99 volts. 27 is full on a 24 volt system. I have mine set to cut off at 27.2. That is fully charged, and you can see it's almost full. And my current draw when I took this picture was 22 point, I think it's 32 or 82 amps. I'm looking at a picture, it's hard to see it on the computer. And that was probably with the mini split and the fridge and a couple of items running, maybe a light. But you can see Solar Array 1 was putting out 0 because it was almost fully charged, and you can see it's in float. So that particular charge controller had decided it had give enough for right this minute, and Solar Array 2 took up the slack, and you can see it's putting out 23.10. So that's servicing the 22 amp current that's a draw, and it still left a little over an amp that it's trying to finish topping off that battery. So you can see I'm only using half of my solar array at this point. I'm only using the one side, and that's just the way it works. It works really efficient. So let me show you one more slide of another one at like max draw, the highest I've ever seen it. Okay, here you can see that it's at 26.53 volts on the battery charge, and the current that it was feeding through the shunt was 60.2 amps. Now that's the highest I've ever seen it. I've seen it get close to that, and that was the mini split just starting up, running at full capacity, and it was hot in the trailer, so it was at max load, and apparently the refrigerator was on and all the lights were on, I guess. Well, I know they were. All the lights were on inside because we were getting ready to load up and get the trailer ready to go, and for whatever reason I had left the air off for a while, so it was struggling to try to catch up. But you can see that's a max load, 60 amps. That's the highest I've ever seen it. I don't think I could get higher than that. Anyway, I've never seen it there again. Now, if I had been on a 12 volt system instead of 24, that number would actually be double. That would be 120 amp. But again, I've got everything. I've got wired size-wise for safety. I'm using 2-aught cabling and 300 amp fuse. So you're just not going to blow that. And then the inverter itself has its own safeguards built in, and it is fusible. So again, I tend to overkill everything. So, but I just thought it'd be interesting to show you guys how well it does and why I just don't worry about it. I just kind of like the old Ronco commercial. I just kind of set it and forget it, you know. And it's just ready to go when I'm ready to go. All right, well, that's it. Hope you guys enjoyed it. I thought you might enjoy seeing what the battery box turned out looking like. We decided to multi-purpose use it, so that bottom slides out and slides back in. And because it's a little bit high, you know, Kathy's short. This is how it turned out. Turned out really nice. All right. Yep.
Well, thanks for stopping by. Just thought everybody might enjoy seeing how the solar works on a cargo conversion trailer.